In production environments, data structures rarely have only one level of data. Usually, data structures have multiple levels of nested data structures, adding more complexity to the storage. The first thing we want to look at is how to access properties that are in nested data structures. You see this example here where we have a number of properties, but some of them hold other data structures. Class specification holds an object which has two properties of its own, and weapon loadout holds an array which has elements. So let's take what we know about the different types of notation with objects and arrays and practice accessing some of these values. Let's create a sentence that allows us to access a number of pieces of data stored in this greater object. We'll go to the outside object and access vessel name to get name. That's pretty straightforward. It's something that you're used to. But what if we wanted to go deeper? If we wanted to talk about the type of the gunship, we're going to need to chain our references. So I'll start on the outside with the gunship profile, go to class specification, and then dig one level deeper and say .type. We'll continue our sentence and let's do one more. This one, we're going to access PDC railguns. So we need to go to gunship profile, .weapon loadout, and then look inside the array and get the value at index 0. So the key here is that you are always starting on the outside, working your way down level by level. In this case, we didn't have to go very far because a string was all that was stored here. But in the case of the type, it was stored inside the object that was the value of this property of the greater object. So we had to go 2 levels down. And then here we were doing a similar process, but we have an array instead of a nested object, so we needed bracket notation instead of chaining another property. Let's run this. And we see the Rocinante is a corvette class armed with PDC railguns. So now that you have an idea about how to access these properties, we need to talk about what happens when you try to make copies of objects like this. There's the concept of shallow copies and deep copies. A shallow copy can be created by using the spread operator to gather all of the properties and place them in a brand new object. But when you have complex objects, it does not clone the nested data structures. Instead, it just copies the pointers to those locations in memory. And that could cause problems because if you think you have a complete clone of this entire object and you start changing the values in a second level or a third level, it's going to change those properties everywhere. So let's test this out. Let's create a shallow copy with the spread operator. I'll call it shallow clone. We'll create a brand new object and then use the spread operator to gather all of the properties of gunship profile. So let's say that our new ship is going to have a different name. We can go to our shallow clone and change the vessel name, and then log some sentences so that we can see how this comes out. Original name was gunship profile.vessel name, and the shallow copy name is shallow clone.vessel name. So let's run this and verify that the name that we changed only belongs to shallow clone and the gunship profile still has its original name, Rocinante. And it does. They have different names. They're stored in completely different places in memory because the outer object was successfully cloned as a separate object in memory. Now let's change a nested value and see what happens. We can go to our shallow clone, go to the class specification and the type, and say this particular one is actually a heavy frigate. And then we'll test it. The original class was gunship profile dot class specification dot type. You run it, And we see that the original class now says heavy frigate, and that shouldn't be true. It should still be Corvette class, but that's because we only made a shallow copy. And it's still pointing to these original nested objects because they're still stored in the same place in memory. They were not copied. So let's talk about how you would fix that. One of the challenges of working with deep copies is that it's difficult to predict exactly how many levels down you're going, which ones are arrays, which ones are objects. The organization of data within an object can change from one object to another, so we need a different approach. You may not have heard of JSON yet in your coding journey, but it's a data format that allows us to send data in a flat state as a single string all over the internet, and that's how we move data from place to place all of the time. JavaScript provides two built-in methods, json.stringify and json.parse, that handles that conversion of data between objects and strings. We can take advantage of this by serializing an object to a string and then parsing it to create a brand new copy that has a completely different location in memory for every single nested object. Let's use these two methods in conjunction with one another. I'll create another constant, deep clone, and we'll say, let's parse the string of the original medical lab. So again, we're starting by stringifying this object, and then this will parse it back into its original structure. So we now should have a deep clone where this object is completely unique, including the array stored in inventory. Let's add an element to that array. So I'll say deep clone dot inventory dot push. That's an array method, right? And then we will say nanite swarms. Okay, once we've done that, now we can compare one against the other. So I'll say original med bay cargo, and we'll go to the original medical lab and check its inventory. Now let's do the same with the deep copy cargo, and we'll replace this with a deep clone, and then print both of these out to make sure that the arrays really are two different arrays. And they are. We see here that it only has two elements, and this one has three. So the main thing to remember is that you just have to be careful about making copies of complex objects because you may not actually be copying all of it. And the solution to that is to use these stringify and parse methods from JSON that allow you to make a completely separate copy no matter how deeply nested this object is. I'm going to make a commit. And let's take a look at the practice. So you have an opportunity here to practice just accessing some of these things and then also working with shallow copies and deep copies. That's all I've got. I will see you in the next one.